Can you hear me?
Yes, ma'am, I'm here.
Okay. So shall we commence with the session? Networking platform and ground level seminars and workshops in major Indian universities, including IITs and IIMs, and communities like GS, GDG, and IEEE. XRDI is India's biggest XR community and is a non-profit organization. XRDI has conducted events in 15 plus universities and 10,000 plus students got benefited from their webinars and live events so far, with the aim of technological growth of India. It has 72 active volunteers all over India powering values ventures by the community. Extended Reality Developers of India represents the Indian XR ecosystem on international platforms like Global Entrepreneur Week USA, GEW 2020, World Leaders Summit WLS 2020, and TII Global Summit TII 2020. The topic of this session is Introduction to Rendering, Pipeline, and Game Engine. Sir, we are really eager to listen to your talk. So over to you, sir.
Thank you, ma'am, for such a great introduction. And I'm really honored to be on this event. Yeah, let me just start sharing my screen. You will be able to see my screen on this only. So you can pin my window so that everybody could see this screen on bigger end. Can you pin it?
Okay.
Yep. Yeah. Okay. So now everybody can see it. Let me just also present so that you can see my screen, right?
Yes, sir. We can see us.
Good morning, everyone. I would like to start the session by thanking IEM Kolkata and TechX Labs and AICTE and Natal Foundation for hosting such great sessions all over India. So let's start this session. We're going to talk about XI industry. So you guys might have heard of several words like VR, AR, MR. Okay, let's go a little back before starting about this session. All right. So I got a lot of feedbacks from the previous session that we did, and a lot of feedbacks also suggested that they were not able to understand a lot of things. So my request to you guys is when I'm asking and for if you guys have any queries or something, you guys must ask your queries, right? So otherwise it would be really difficult for me to continue if you guys don't have the base understanding. So before going to this one, please unmute yourself and let me know what were the queries from the previous sessions. Or a lot of people wrote that they were not able to understand some of the concepts. So would love to listen to your uh, doubts and whatever the problems you have with the previous session. So to remind you, previous session we did was, let me also open the previous session slides so that we can go over that and talk about those as well. I got the feedback from everyone, and everybody, uh, some of those recommended uh, that there was some problems with the session. So let me know that which part from the presentation you guys had problem with, uh, so we can go over that. We did this session last time that there is no spoon, neither 3D models, right? We talked about binary number system, the decimal number system and how they correlate. We talked about the map, conversion between characters to binary, then conversion between emojis and symbols to binary, then conversion between RBG values, yani color, then to binary. Then we talked about how all this emojis and symbols has a map as well. Then we talk about these images and how images are translated into binary. And then we talked about the world first video and how videos are constructed through each and every individual frame. Then we talked about what are algorithms and how the fundamental of algorithm. Then we talked about specifically 3D rendering pipeline and what are the steps in those pipelines involved. What is vertex processing? What is tessellation? Then what is fragment processing? And then final output is out. If you have any questions regarding that, we discussed some of the softwares, the artistic tools which allow you to create these tools which allow you to create these models, and these models are nothing but these values which are which comes out as a output format from these models. And then finally we use these models into Unity and Unreal and Buildbox to create some sort of simulation or virtual reality thing. But whatever we create is still on a 2D screen and a 2D thing. So how do we perceive depth? So to understand depth, we talked about binocular stereoscopic vision. We talked about how two eyes sees two different images, and if we replicate that, we can create the illusion of depth. We talked about several good ways of doing that. We talked about how we can record 3D depth. We talked about the 360 camera. We talked about several variation and a very one slide history. However, we also do sometimes 10 20 slides history about VR, but we didn't have time for that. So over this session, who had any problems, please unmute yourself. I would it would be easy for me to continue if you guys tell me your problems. Yeah, I guess there is one question. Permission. Participants have unmute permission.
Sir, actually, that has been posted from our end. So all the participants have been given unmute permission. You can unmute yourself and ask
Yeah,
your
now you guys
queries.
can unmute and ma'am, can they unmute now?
Yes, sir. Yes, all the participants have been given the unmute permission.
Okay, okay. You guys can unmute now and ask your questions if you have any. It would be easier for us to continue. I don't want anyone to have some sort of breakpoints where the entire simulation breaks in their heads. And ma'am, also, can we have the recording for the last session?
Absolutely, sir. I
Thank
will
you.
make arrangements so that it will be made.
Yeah,
Absolutely.
I can go over the sheet and look for who said that they didn't understand. So please ask me questions if you still have the misunderstanding about some of the concepts. I would love to go over them if required. And please, I have worked a lot of time with doctors, and the best thing about doctors is they are very happy and they are very light about saying that, oh, I don't understand this thing, and I learned this from them. That if you don't understand something, just tell them. Nobody knows everything, so it's an opportunity to learn when we don't know something or when we are not able to catch up. Please utilize this opportunity.
Participants, kindly unmute yourself and ask your query. Whatever doubts you have, you can ask.
Ma'am, your voice is really low. Can you?
Hello, sir.
Yes,
Can you
ma'am.
hear me now?
A little bit better, ma'am.
Oh,
Yeah.
all right. I request all the participants to kindly unmute yourself and ask your query. Sir, I can't find any participant unmuting themselves.
Okay. Let me just go through the sheet. I guess I can find them. I'm sorry if I am wasting the time, but it is really important for me to go over that. Otherwise, you guys will be missed out, and I don't want that, right? Uh, there was one section with suggestions. Where is it? Yeah, you can see here there is a comment that it is very difficult for somebody like me who's a beginner. So whoever wrote this can ask their question. Again, there is one more really difficult for beginners. Uh, the session we did last time was supposed to be for beginner and was supposed to be to get everyone on the same ground. But if somebody has confusions, we can go over. No worries, then let's continue with the today's session. And still, if somebody wants to ask, they have time. Ask me anything, anytime. Okay, so now we are going to talk about XR industry and XR introduction. So we are talking about VR, AR, MR, and several other terms. Actually, there's one more term called CR. CR is a cinematic reality, and this very term XR is my favorite. And the reason why XR is my favorite is this X is basically a variable. So you can replace this X with any other term. So which means this acts like an umbrella term for all other terms. So XR could also include VR, AR, MR, and everything else. That's why I named my community called Extended Reality Developers of India. All right. So now let's talk about some of the elements which are involved in this. So let's talk about digital and virtual. I guess I spoke about this shortly in the previous video as well, uh, but here would love to repeat. So one second, am I audible correctly? Let me just check with everyone. Yeah, it looks like I'm audible. Awesome. So there are two terms which are almost like same treated as same, which are digital and virtual, and we use them without understanding them very much, and we use them without vice versa, we replace them wherever we have to. But actually there is a very small difference between digital and virtual. Digital is meant to be understood by machines. Digital is everything which is in binary. So, for example, if you are sending a text from your phone to somebody else's phone, then that conversation is basically purely digital, which means the message is going in zeros and ones. One machine to other machine communication is happening in zero and one. And your machine treats every data as zero and one. So that is digital. But the screen you are looking at right now, all these characters, all these words, these are not meant to understand by machine. We need to do a lot of work to for machines to be able to understand the very word spatial audio and what does it mean. We need to come up with something called NLP, natural language processing, and everything, and image recognition and everything, to be able to understand the virtual things to machine, even the virtual things to machine, right? So virtual is meant to be understood by humans and not machines, but the digital is meant to be understood by machines. One short example for this, to proof or to make it understand clearly what I'm saying, right? So let me just take a picture. This is a fan art that somebody made for me, right? So let me just try to show you. So you can see this picture and you can understand that okay, there's a pixel art and somebody is looking in this picture. Okay, some guy is there with the beard and the headset. And so this is a digital sorry, this is a virtual picture. But this information, if I open the same picture in a notebook, right? Now the same information, these two pictures, this one picture is opened in two formats right now. As you can see, this is the same name, Ankush fan art JPEG, and this has the same name. So these are same files, but this one is written in some sort of gibberish. It's not even 0 and 1. I'll tell you why it's not in 0 and 1. But this is clearly something which human can understand. This is clearly what a machine can understand. And this is what we call digital, and this is what we call virtual. So this is exactly the difference. The same thing, but different. One to be understood by machine and one to be understood by human. So why it's not 0 and 1, when why it's just stupid characters here and there? And the answer to that is basically the text editor notepad what I'm using. It's not meant to be understand by machines. It's a human editor. So for example, if I open a new file in text and write, it writes in English. So if I write my name, Vidivedi, so it's something what you can understand. So it's already write in English language, right? So when it saw something like this, where is it? Hold on. Okay, no worries. So when it saw something like that image, so it was expecting to read it in English, but it was not in English. So that's why it was projecting some English format of that zeros and ones, right? So it was making no sense because it was not English. It was some image data, right? So the expected input for Notepad was English, right? So we understood what is digital and what is virtual. Now, what is virtual simulation is basically when you create some physical phenomena in form of virtual format, I would say. Okay, so what is virtual simulation? Suppose there's a physical phenomena. What could be a physical phenomena? Like anything, like raining, like dancing kangaroos. I don't know what, and then like a train going through a tunnel, anything, right? And if you can construct that that physical phenomena in a virtual way, if you can express that, then that particular thing is called a virtual simulation. All right, I hope that is simple. So now, what is virtual reality? The idea of virtual reality is creating a virtual world now with these virtual objects, which means which could be understood by human. So now this we try to create a virtual world, and since this is a virtual data, which means it could be understood by human, so we also try to put a human inside this virtual world. So the very virtual reality means we are putting a virtual we are creating a virtual world and putting a human inside that virtual world. Now, augmented reality. What is augmented reality? Augmented reality is little bit just opposite of that. In augmented reality, we are bringing some of these virtual element and pasting on top of this real world, right? How do we do that? We are going to understand in the next slides, but the idea is opposite of virtual reality. In virtual reality, we are putting someone in. In augmented reality, we are getting something out of that virtual world into the real world. All right. So, what is mixed reality, by the way? Mixed reality, you can call it just a marketing term. So, in 2015, what happened that Microsoft came up with a headset called HoloLens, and they introduced this term called mixed reality, in which if the augmented reality device is mounted on the head, it's called a mixed reality device. So in mixed reality, there is also a concept that in mixed reality, VR and AR both could be used. The same headset could be used as VR and AR. So mixed reality is sort of the blending the barriers between what is virtual reality and augmented reality. Then we can talk about virtual haptics. So what is virtual haptics? Is basically the idea that if some virtual object is there, I should also be able to feel it. And how could you feel some sort of virtual object? There's no possible way, because the object does not exist in real and physical space, but all your sensations are in physical space. So how are you gonna feel that virtual object? The answer is robotics. The answer is mechanics. Somehow we use mechanics and robotics to create the sensations which aligns with that virtual object. I'll give you a demonstration of that as well. Next is spatial audio, which we need to understand. Spatial audio is basically an AR Rahman song. So suppose you are going to a movie theater and something happens, some sound, type of sound appears, and you know from this sound is not coming just directly from the screen, but it is coming from maybe from left, maybe from right, maybe from behind, which means with the sound you also get the very direction and the very distance of that particular sound. All right, so you can imagine that from this sound is coming from left or right. Right, so not just left, right, above and below and everything. So we give a more spatial perspective to an audio. There are also location based properties which you can leverage in XR. So, for example, if you know that the person who's using the XR is in California, so you can replicate the weather of California and you can project that in VR. You can use that data, or you can also give some sort of local hyperlocal landmarks in front of them to make your simulation more real to him. That okay, I remember this place, I correlate with this particular simulation more because I remember this place. Okay, so what is VR industry and how big is VR industry? Answer is it's huge. This is a landscape of 2019. In 2019, there were a lot of companies working for VR and AR. In 2019, it was a 1.5 billion dollar industry. This is 2020. It's hardly ever even fitting here. So as you can see there, I can even tell cannot even tell all the logos. There are so many without zooming, and zooming is will not work in full screen. So there is advertisement and marketing, there is art and design, there are books being built in virtual reality and augmented reality, there are businesses, there are distributions, e-commerce, education, enterprises, entertainment, games, food and drink are taking advantage of VR and AR, health and fitness, kids, product, lifestyle and location based services, navigation, peripherals, and medical, and so many things. Like I cannot even read all. I don't have time for. Right. So all these products are taking advantage. There is hardly a tech company which you know and which is already not working in some ways in virtual reality. They all know that this is the future, and they all know that in next 5 to 10 years, it's going to transform how we use computing. All the computers you use somehow gonna take advantage of VR and AR in some ways. So that's the ideal situation. So for example, if you whatever the room you are sitting at, so for example, I'm sitting in my room, and that room already has more than 19 screens of somehow. There are iPads. I have 3 iPads here. I have 2 phones, one computer, one laptop, one this BP monitor and everything. So there are several kind of screens, and the idea of augmented reality and mixed reality glasses is basically combine all those screens into one. You just wear a glass and you can get the relative information whenever you want. So you don't require an Apple Watch because you can look at your wrist and get the relevant data on there. All right, so let's. There is a slide missing, but no worries. Okay, so as I already said, these are some normal, or I could say, these are some fields in which you basically see right now virtual reality is being adopted, and you can see there is almost every field, right? from games to scientific simulations to education to journalism. All these sort of fields are taking advantage of from virtual reality in one way or another. So now my question to you is, how is it possible? And the answer is, it's possible because virtual reality is not just a technology; it's a medium, and medium means your television is a medium, your radio is a medium, your mobile phones are medium. Medium means you convey your thoughts with that, you tell stories with that particular medium. What you consume on your mobile phone, you consume everything, right? From religious videos to journalism and news to entertainment to fitness content to educational content. Anything could be communicated through a medium, and virtual reality is the next medium. So it does not really just limited to the use cases. It could be adopted in several industries, but we have to right now check that whether putting a headset on the user's head is going to worth it or not. So that's why we still evaluate. So for example, whatever we can do on 2D screen, it's better to do on 2D screen. But whatever can take leverage from doing on 3D screen, we do it on 3D screen. Awesome. Here is crazy example I'm gonna show you about virtual reality. So there's in Korea, in South Korea, there was a 7-year-old girl who passed away, and her mother built this simulation with the help of a team, and they bring back in virtual reality her daughter, so that she can celebrate one more birthday of her and spend some more time with her. And she's wearing the haptic glove right now, which means she can feel the presence of her. She can touch her and then touch her hands. So there's no limitations of what we can build with virtual reality, and there are unlimited horizon ahead us. All right, next we are going to talk about what is virtual reality again. All right, so in more technical ways, virtual reality is an attempt of fooling human senses, and the goal is to create a fake environment that our senses perceive as real physical world. All right, so creating something which uh, human sensations feels as real. The idea is to hack all our human senses. How do we perceive reality at the first place? We have five senses, actually more than five, but let's call it five. We have more than five senses, and we perceive all sort of presence, all sort of reality in it through those five senses. But what if I can hack all those five senses? You see from your eyes. What if I can make you wear a glass where I see you, where I make you see a fake reality? uh, what if I can make you hear some fake noises through a headphone? So that's how we are keeping hacking on all those five senses, and we are feeding a fake signal, a fake reality, and then that is called virtual reality. So let's gonna talk about in a very high level some of the technology of virtual reality. So there is it's stereographic vision. So when we are talking about stereoscopic vision or stereographic vision, so basically I told you how we perceive 3D is basically we send two different images in your eyes, and that's how you perceive depth. I explained that in previous slides fully. I also talked about computer graphics. That computer graphics is basically the science of generating objects from from the objects from the line of instruction or line of code, right? So the input is the mathematical instructions, and the output is visual images. What is image processing? So we use a lot of image processing when it comes to VR and especially in AR. All right. So I told you that in AR we need to do a lot of image processing, and in VR as well for a few processes. So image processing is basically an attempt to make a computer understand that what is visible in the image. So make a computer understand that the image in the image it's a cat or a dog, or it's anything, right? Making computer understand that what is the context of that particular image in several ways. So next, projection and mapping. Projection and mapping is the most important part since it involves real virtual mapping in the real world. So for example, we use a lot of sensors, and we whatever the movement we do in the headset, we have to replicate the same movement in the virtual world. And for that, mapping to the real scale world is really important. So we use this calculations called projections, and projection is like the algorithm which you require for doing any sort of computer graphics or science even. If I have to send a probe to moon, I am gonna making like a million, a billion of projections calculations, because projection is something which is used in every sort of engineering. You require some sort of projections. It's being used in your lifts, is being used in I don't know, car mechanisms, gear ratios. Projection is used everywhere, and it's a powerful algorithm. I'll teach this algorithm in several sessions. I teach all those algorithm in I'm making a series for that as well. So parallel processing. Parallel processing is very essential for virtual reality, especially because the entire computer graphics happen on large images. Uh, there are in an image there are like 1920 times 1080 pixels, which means approximately a million pixel in one image, and that sort of calculation. If you have to even make a brightness up for one frame, that's gonna take a million transactions. That's gonna take a million instruction. So even making a brightness up gonna take millions of instructions, which means doing this for 30 times a second, or in virtual reality case, you have to do it 90 times a second at least, and for two eyes, which means it becomes 180 times a second. It is a very graphic, it is a very intensive process, and you require a different kind of processing to solve this. So we use a different sort of processors called GPUs, or graphic processing units. They are also called parallel processors, and they are like simple processors, like normal processors, but their core are they are consist of multiple cores. So all the processing is divided between all those cores, and they do solve the very image non-sequentially, uh, and that's called parallel processing. Then we come to projection and mapping. Oh, okay, we already been there, right? Okay, inside and outside tracking, right? So previously, the headsets used to come up with outside-in tracking. All right. So outside-in tracking were a different arrangement of sensors. You require a room setup for this sort of tracking. So you mount the very cameras on your wall, and those cameras look for different kind of markers which are placed on your headset, and they track those markers, and that's how they localize your position in the room, and that's how they map your motion back to the virtual motion, map your the physical motion of yours to virtual motion. And let's talk about inside out tracking. Inside out is a completely opposite way of tracking, in which the camera sits on the head mounted display, which means on your HMDs you have some sort of cameras, and they based on whatever the motion is happening, they do the inverse calculations of that particular motion, and they try to understand the very motion of headset, and they also try to localize the headset in the relative space. That's how that's the algorithm called SLAM. So SLAM is basically simultaneous localization and mapping technique, which is there for long, but it was perfected like nearly very recently. We were able to perfect this algorithm because there is a lot of complexity going around. A lot of we have to take care about a lot of noise in the data, the lighting conditions of the room, and there are a lot of complexities. It is the hardest algorithm to perform on a device. Because of computing processing power upgrade, we are now being able to perform this use this algorithm. Otherwise, outside tracking was the way to go for a VR, but now the headsets use inside out tracking and SLAM. Now let's talk about augmented reality. Now there are really the three parts of augmented reality, which means augmented reality is constructed of three things. One is reality, second is intelligence, and the third is addition, you can say, or augmentation, you can also say. So what is reality? Reality comes from your camera feed in most of the cases, but also you can replace the reality with anything. Like if you are, for example, doing some sort of projection, like normal projector work, so you can also use that reality, which is like real reality. Okay, so in augmented reality, the reality part comes from the camera, but you can use any physical sort of reality as well. Then comes the intelligence part, which means you have to understand what is in the reality. So, for example, you have a cat in reality, you have a man in reality, a woman in reality, or a kid in reality, or a hand in reality. We don't know. We have to use some sort of computer vision to understand that. And there comes the intelligence. Your algorithm has to be intelligent enough to recognize what is there in the reality. And the third part is when you understand what is there in the reality, you do some sort of addition on top of that. Augmented reality is literally the meaningful augmentation, meaningful addition, doing addition to our image in such a way that it is meaningful, which means we require some sort of intelligence. All right, so we have here some tasks to do. This is my image at a presentation. So this is reality is there. All right, we require some sort of intelligence and augmentation. So let's say this photo of mine is a reality, because yeah, we know this is a real world object, so we can call it reality. Now this tick is done. Now we come to next step. Let's add the next tick. So we need to use intelligence, and let's find head. Okay, where is my head? Okay, I know this is my head. All right, we don't need to select anything, but this is my head. I am using human intelligence to recognize that where is the head. I say, okay, this part is the head part. And the third part is augmentation. So now let's augment it with some ways. So let me just find cap. All right, we found a cap. All right, which one is better? I guess this one is better, but we need to flip it. Okay, let's flip this horizontal. All right, okay. So we use a lot of intelligence there. We also flipped it. Okay, awesome. So, awesome. So now this image is augmented, right? We have all three check marks done, which means this is perfect example of augmented reality. Uh, One second, let me just make the presentation great again. Okay, okay. We have the reality which is coming from camera. we use intelligence. In this case, we use human intelligence, my intelligence, but generally we use when it is completely automated, we use the device intelligence, right? And the third part is augmentation. So we added a cap on the head. So what we did, three steps: added a picture, which is like adding the reality using intelligence. I founded my head, that where is my head. And the third part is augmentation. Based on the localized point that I know that this is my head, I added a cap. So cap is augmentation. And the overall process is called augmented reality. Alright. So this is an example of augmented reality which I built. I'm not sure you will be able to listen the audio or not. Hopefully you will not be able to listen the audio, but you can also visit this. You can also type this Angpatra AR 2.0 after this session, all right, and you can listen to the audio because this one speaks.
Today is 4th August 2020. 261 days ago, Earth with COVID-19 is the infectious disease caused by the most recently discovered
So it's
coronavirus.
telling us about COVID-19. It's
18,359,079
showing us
people
all
are
the
so far
numbers,
affected with the
but the
coronavirus.
background
USA is
is
the
my
most
home.
affected country in
I'm
the
doing
world
this,
currently
running
with
this simulation on my home, and this is
4,860,862
looking at
confirmed cases and
that this exists in real space.
174 deaths so far.
I can see that USA is on top, Brazil is on second number, India is on third number. Again, this is a video, so the numbers are like really old. The video is from last year. Okay, so we can see some sort of information. We can
India
go
has a total
and
of
type for India specific
1,855,331
information. Here were the numbers from India,
cases so far. A positive news
and
is that
it's visible in my room only. It's
66.32% of
above
them
my
have fully
TV.
recovered, but unfortunately, country saw 38th. Maharashtra has
Okay, I can select some state and
450,196 confirmed.
that
CH
state's number will
Chhattisgarh
be
has
there,
9,820 confirmed cases, with
and there are
61
all the
deaths so
ratios
far.
of all the states. All right. We can also see a lot of news here. So here in the space, in the very void of my home, I can see a lot of COVID news floating on the room. Okay. And here is some sort of video player. So I can also choose a video from the right. I chose the video from the right, and it will guide me about that particular video, so that we can spread the fake news and spread the awareness about COVID-19 in the proper way. So these are some authenticated sources of information for COVID-19 which I added. So, and the whole app is in augmented reality. So it's an example of an AR app. So yeah, we have like 15 minutes left. More than 15, I guess. The session is supposed to be over by 1. So I guess, yeah. Okay, so these are my information. Connect to me if you have any queries or something, right? I do recommend this link called XRDI TV. And when you go to this link, you will be amazed, or maybe not. But this is a good place to learn things. You can learn plenty of information about augmented reality in several ways. Whatever you want to watch, please watch. Okay, so uh, now I'm gonna tell you about there is a video that how you can install Unity, and that video is also on this channel. So you can search about Unity or install Unity here, and it will guide you that where to go. Or I'll also share the slides, so you can also go to this particular link and find the video. I'll share this slides with you guys. I'll share the previous slides as well. I forgot to share the previous one, but I'll share this one so that you can go and watch this video and visit this video or visit the channel as well. All right. So why I want you guys to install Unity? Because of the next step we are going to do. I'm going to open Unity. The installation process is covered here, so you guys are all covered. So just watch this video carefully and you will be able to install the Unity software by yourself. If you guys still had any problem, connect to me. I'll help you in the installation process. Okay, so we have this. Let me try to create a new project in Unity. So I created on new. I'm going to create one project, but I'm not going to create in the GitHub folder because that's a working space I like to work on. Okay, I'm going to create this in this folder somewhere. Okay, so let me name it IEM Unity, wait, Unity demo. All right. Okay, this is fine. IEM Unity demo. Okay, so now Unity is creating a project for me. It will create a garam project, empty project for me. Its opening project is taking its time. Meanwhile, I'm sure you guys have a lot of queries. Please ask.
Participants, you can ask your question and write it down in the chat box.
You can type the questions in the chat. You can do whatever you want. But it would be awesome if you guys ask a lot of questions because it will help you and it will help me too. Yeah, Unity has created the project for us. So yep, here it is. So when Unity creates a project for you, it creates with this sort of layout. You can go to layout and change the layout by whatever the way you want. I prefer 2 by 3. 2 by 3 sounds really cool to me. So I choose 2 by 3 all the time. All right. I'm going to give you an example of rendering. I told you there's something called rendering, but I didn't show any demo. So let's do some demo of rendering. Right. I clicked on, did a right click in the hierarchy. Let me just explain this. I explained in that particular video, but let me explain it here as well. So there are some windows which you need to understand about Unity. All the windows are dockable, which means you can use them separately. You can dock it anywhere you want. You can grab and dock it here. You can grab and dock it here, right? So these are some windows. All the whole Unity is divided into these sort of dockable windows. There are name on the windows as well. This window is called scene window. You can say it's a direction zone. You can place object wherever you want in this particular zone. Okay, if the movie is there, this is the backstage. You can arrange whatever you want to do from here. What is camera? So to make you understand what is camera, let me create an object again. Okay, there is a cube. I added a cube. As I said, you can make the things wherever you want here in the scene window. You cannot make the cube change position here, okay, unless it's not a feature. You cannot do it here. In the game nothing will happen to the cube. In the scene something will happen to the cube. You can place it here, you can place it here, you can place it here, wherever you want, right? You can see. Okay, so this is called cube. This is called scene. In the game window, there's something called camera. There's an object called camera. It's called main camera. Okay, and main camera is looking at this cube. Okay, so whatever your cameras are looking at, whatever the camera is looking at, it's going to be shown in the game window. It's like the final picture. here the actors are acting something, they are doing something, and this is the final picture which is being rendered, right? This is hierarchy. Hierarchy means the list of components which are active right now. So you can also make it deactive, which means it will disappear from your scene. Okay, so this is the list of objects which are acting in your scene. Okay, this is a scene, and this are the list of objects that are present in your scene. Similarly, this is called assets. It basically points to a project folder. So if I go show in folder, so this is pointing to our IEM Unity demo. This is called assets folder. All right, this is pointing to that particular space, and you keep your stuff here, so you can use all those things which you have put it here. If you have to use anything else from your disk space anywhere, you have to grab it and put it there and then use in the assets. You put it in the assets and then use it from the assets. So for example, if I have to use that cool image which I had, yeah, that cool image, the fan art, I have to put it in the assets folder. There are several ways. I can drag directly, or I can open it here and here. I can go it here and go to here and drag it, and now go back here, and you can see the photo is appearing here. Now you can see the photo is here, the fan art is here. So I can create folders here in the assets. Let's call it images. You can also call it textures, but I don't want to go there. Okay, so we have added one folder for images, one folder for scenes. What is scene? This arrangement is called a scene. Okay, this hierarchy and arrangement is called a scene. Whatever changes you made to the hierarchy, when you save, it is saved in the scene file. Okay, this section is called inspector, and there are a lot of properties in the inspector. Like there is first I said enable and disable property. Then there is a very cool property called transform. Transform has several components. So there is a component called position XYZ. I told you that how every position is a three-dimensional position in rendering. I told you about the vertex point and everything, right? So if I move the x-axis, if I make the changes in x-axis, the cube moves in the x-axis. If I make the changes in y-axis, it moves in the y-axis. If I make the changes in z-axis, it will go far and come back closer, right? Similar with rotation, rotating in along with x-axis, rotating along with y-axis, rotating along with z-axis, and similar with scale. You can scale in this direction, x-axis, right? You can scale in y-axis, you can scale in z-axis, right? So uh, you have heard a term called animation. 90% of animation is just this three component: position, rotation, and scale. From this three component, you can create 90% of the animation. Rest 10% is like super hard. 90% is easy, that comes from here. But that is also tough when you have to do a lot of keyframing. But the simple idea is this. Okay, so we have our cube here, and it is doing something. And okay, now my question to you is how this magic is happening. You know, this camera, this camera is not a real camera. It's not a physical camera. It's not clicking pictures. How the picture down there is moving. Okay, there has to be some way, some mechanism. I explained the mechanism in the previous video. It's called rendering. Okay, so to show the mechanism, I'm going to show you one example of script. I'm going to write a script quickly. Okay, so create a folder, call it scripts. Okay, go inside the folder, right click, create a C# script. We code in C#. Okay, let's call it rotator. Okay, I called a script called rotator. I'll come to how to code it, but let me just explain that as well. Okay, in Unity, when you create a script, the script inherits a class called mono behavior, right? For Unity, there is a class called mono behavior, and this class resides in this package called Unity Engine. If I delete this, you'll see the mono behavior is giving me error. It's saying that I don't know what is mono behavior. Okay, so let's add the package again using Unity Engine dot mono behavior. Okay, using Unity Engine. Fine. Okay, so here are some comments for us. It's written that the start is being called for the first frame. Start is called before the first frame. Even the first frame has begun. Even the very object has started rendering. This particular start function is being called, which means it is the first function. Actually, not first. I'll tell you how, but let's see. Okay, then this is called per frame. Okay, I'm going to do something. Let me just bear with me. Public vector 3. Okay, rotation. All right, here I'm going to do some transform dot rotate and rotation. Okay, now in Unity, when you make some object public, it gives us the very object a superpower, and that superpower, it will be listed in the inspector. So I have to use this script. I'll keep it and drag. I can drag it here, or I can also drag it here. Okay, the rotator is added. What the class I added there? The class is called vector 3. Vector 3 is basically 3 float value. So x, y value, x, y, and z. I got the access to 3 floats. Let me put a number here called, let's say, 2. Okay, and let's run the script. Run the game. Something will happen in the game. The cube has started rotating. All right, but I'll go to in the mechanism that how the cube is rotating or why the cube is rotating. So let's see what we are doing here. Let me remove this start because we are not using it. Okay, so the update is called once before a frame is being rendered. All right, and then the frame renders. All right, what does it mean? It's like a camera. I told you the camera is like a camera. Okay, so this update, this mono behavior tells us something about the camera. This is giving us the access to that function which is called just before the photo is clicked. It's like telling us that, okay dude, I'm going to click a picture, please make sure your tummy is in. Okay, so it's telling us, okay dude, I'm going to create a picture, and you just do whatever the changes you want to do in that particular frame, and after that, after this update is over, that Unity clicks a picture. Okay, and this happens so fast, it happens in 1 second 90 times. Right, let me actually show you how many times it's happening actually 170, sometimes 180, one time, sometimes. Okay, the average is 90. You at least require 90 to work in VR. You at least require 60 to work in PC games or something, right? And you require at least 30 to run any sort of game. If you run any game below 30, it will be laggy. Okay, it will lag, your game will lag. So we are getting 120, 130, 170 frames sort of right now, which means the camera is clicking 144 pictures, 170 pictures in 1 second. In one single second, it's clicking a lot of pictures from this cube. Okay, and before every picture, we are rotating our cube by a smaller distance. How many, what kind of angle it is? It is a 2-degree angle in the y direction. So what is happening? Let me stop it. Okay, So the Unity gives us a powerful function. If you press it, it will move by just one unit, one frame. So you can render things frame by frame. So now what is happening? You can see the some value there. Okay, some value 0. Okay. So what will happen if I click next? Let me tell you. It will the function will go here if I click next, and it will check that what I have to do before the photo clicks. It said rotate by this particular amount of rotation. What is the amount of rotation we have provided? We have provided 2 degrees in y-axis. Okay, so when I'll click it, it will go to go and check that how much rotation has to be done, and it will rotate the cube, and then Unity will click a picture and it will come back to pause. Okay, so let's see what happened. Okay, it rotated. We didn't notice, but we can see from 0 it is now 2. Next, what will happen? From 2 it will go 4, 4, then 6, 8, 10, 12. Similarly happening, right? You can see the rotation being increased. We are running frame by frame, and in each frame you can also see the cube rotating here. You can see it rotating a little bit, right? So we are rotating frame by frame, and it looks like that it is moving, but it is not actually moving. It is rotating frame by frame. It rotates something, it does something, and Unity clicks a picture. Does something, clicks a picture. And when it happens so rapidly, it looks like motion. But there's no such thing as real motion in game engines. So I guess this is the introduction to game engine. And now we can come to whatever the questions we have. Yeah, guys, go ahead. Bombard me with the questions. I would love to deal with questions. Please don't go mute like always.
Max, if you have any questions, please post it in the chat box, or you can unmute yourself and ask your question. Participants, you have the permission to unmute yourself. So whatever questions you have, you can unmute yourself and ask your question.
Yeah, please ask question. I guess I'm suffering from the same problem you guys are. I want people to ask questions so that I can know that where they are and what they are able to grasp. Last time I guess I flew too fast because I thought that you guys are already doing machine learning, you guys are already doing quantum computing and everything, so you guys may know about binary, so that's why I flew too fast. And there was also no resistance from the team. Nobody asked questions to stop me. Please stop me wherever you don't understand it.
Any questions from the participants?
Please ask question, everybody. Don't go silent, otherwise it will not result into anything, and the certificate you wanna earn is going to be a waste, nothing more than waste, if you don't learn it. And also the most important part, uh, also introduce your team, also introduce your students to the community we have India's largest virtual reality and augmented reality community. You can learn from not just me but also from tons of speakers. Let me just make sure that you guys can see my screen. Yep. So this is a beautiful community we are trying to create. You can see plenty of stuff there. You can see XR podcast sessions. This is a yeah, this is a podcast which we guys do, where we invite people from all around the world who are doing fantastic job in virtual reality. I have invited from movie producers, movie directors, to astronauts, to doctors, and they all are using virtual reality in some ways. So it's a beautiful podcast to look forward to. There are plenty of tutorials. One of them I suggested you as well. There are virtual reality tutorials, augmented reality tutorials available there. In the playlist, you'll find a lot of good stuff to recommend to your students and to learn for yourself as well. There are AICTE faculty training sessions from our previous sessions. Previous some of the sessions are there, so you can also take advantage of that. We did some sessions which we are not doing today, but last time we did different sessions, so you can also take advantage of those sessions. Uh, there is sessions from Generesh, who's also the official person from Unity at the time he was giving the sessions. So, which means you can understand that the very tool, whoever the tool is created, he is official guy from there. So you can learn very great insights from the sessions. So there is plenty of stuff to learn from there. Uh, I guess uh, you're gonna binge over it. So and then today's session is also streaming, so you can also take advantage of any session. Uh, Please introduce it
Sir,
to your students. Yeah.
sorry to interrupt. There has been a request from the participant, one of our participants, to share the link of this YouTube channel in the chat box if it is possible.
Okay.
Yes, sir.
Yeah, I got it. I'm sharing you the link. I'm sharing you link of
Oh,
this session and the previous session as well. Just hold on.
yes.
So what happens after the session? I got bombarded with the messages every time that okay, I don't understand this, I don't understand that. But at the time of the session, you guys don't ask. You guys want some personal experience or something. It's nothing wrong in saying that I don't understand it. Of course, if you are doing something for the first time, you don't get it. The very thing you learn from, I guess, trying. Uh, I do a sport called inline skating, and the best thing you learn about skating is nobody in the world has learned inline skating without falling. So you have to fall to learn it. There's only one way. Okay, I have added the links for the both session slides. You guys can take advantage of that. Please install Unity next time for the next session, because in the next section we're gonna make a VR app and a augmented reality app as well, which is tomorrow. And please ask question, yeah. I don't get it if it's not possible that everyone get it. Not possible that nobody get it, and it's not possible that everybody get it. Cool, awesome, great session. Bye, guys.
Participants, if you have any question, I mean, there has been repeated requests from the speakers. If you have any question,